All right, Unit 4 is all about properties of quadrilaterals. Section 1, we're going to first talk about some of the properties of polygons before we get to how they relate to quadrilaterals. So first off, a convex polygon is a polygon whose interior angles are all less than 180. Another way to think of that, any straight line through it will stay inside the polygon. So all of these interior angles, if you were to measure each of these, they're going to be less than 180 degrees. Okay, another easy way to kind of check that, make sure that it is a convex polygon. If I draw a straight line going through this triangle, it never goes outside the triangle and then comes back in. Okay, it'll always just cross through at two spots, like here and here. Okay, that's not true if we have what's called a concave polygon. A concave polygon will have one or more of the interior angles, the inside angles, being greater than 180. Or you can think of it as a straight line through it will go outside of the polygon and then come back in. So if we look at these inside angles, these ones are all going to be smaller than 180. Okay, they don't go past or bigger than a straight line. This last one though, this piece right here, this one is bigger than 180. Okay, a straight line going all the way across doesn't necessarily complete this. This goes past or beyond that straight line. So even though this is one of the angles inside of the polygon, it goes way, way bigger than 180 degrees. Another way to think of it is, on the outside of this figure, it kind of makes this dent, or like this mouth. Kind of makes it look like a little Pac-Man thing. Okay? If it has that kind of Pac-Man shape with that mouth, that would make it a concave polygon. Okay? And if we wanted to do the line test with it, let me get a red line. If I start right here, now if I just cross like this, it stays inside the polygon at all times. But if I move it across right here, now you can kind of see where it crosses here, 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 and here. It crosses it 4 times. It should only cross twice. And that's because from this area, in this little black spot, it's actually outside of the polygon and then coming right back in. So the straight line going through it will go out of the polygon and then come back in. One more note here. I'm going to get rid of these. Show you with some lines. Polygon sides cannot cross each other. So if I tried to make a quadrilateral going from here to here and then down here, I can't go from this side and come back like this to make a quadrilateral, because then it would cross right over here. Okay? I tried to do 4 sides, but they actually got crossed right here. So we'd say this is not a quadrilateral. This is not a polygon. Okay, because these 2 sides cross each other. So let's take a look at some naming of polygons. Don't write all of these, just write these ones on the side. So go 3 down to 12 and just write down some prefixes of these. So 3 has a prefix of tri, so like a trigon. We call trigons triangles. Those ones, it's kind of a different naming system. 4 sides on a polygon would be called a tetragon. Again, we call those quadrilaterals. Everything else after 3 and 4 does follow these rules though. So you could say 5 sides is a pentagon. 6 sides is a hexagon. 7 is a heptagon. 8 is octa. 9 is nona, so a nonagon. 10 is deca. 11 is undeca. And 12 is dodeca. You make a dodecagon. So just write these ones down off on the side. And kind of below that, make yourself another note. If you're not sure of the name, you can always just say an n-gon. So if there's 11 sides and you can't remember that it's an undecagon, just call it an 11-gon. That is acceptable. Same thing, if you can't remember 9 is a nonagon, you can just say 9-gon. That'll work as well. Okay. The rest of these, if you want to write down some of these other ones, this goes all the way up to 20. You can write some more of these prefixes if you want, but you don't need to know those ones. I'm more concerned with 3 through 12. So let's try to name a couple of these. Polygon like this. Again, if I were to take a line out here, anywhere I go, it'll only cross the polygon at 2 different spots. Oop, I have to go all the way through it. It only crosses it at 2 spots. Also notice it doesn't have like a little mouth in it, so we'd call this one convex. This one is also convex. Again, anywhere that I try to cross it, it only is going to touch 2 spots on there. Okay, so this is a convex polygon. So this one, though, if I try to draw a line like this, it'll go outside of the polygon. It crosses right here, here, and here. And in this area, we're no longer in the polygon. We went outside. That's why this one would be a concave polygon. Now, if you also wanted to name what kind these were, you call this a fourgon, or a quadrilateral, a fivegon, or a pentagon. This one also has 1, 2, 3, 4, 5. So this would be a concave pentagon. This one, if we do our line trick, or again kind of look at it and we see, oh, there's no mouth or no dent, this would be a convex hexagon. There'd be 6 sides here. This one would be neither. It's not convex, nor is it concave. Okay, this one, like we showed before, if I try to go from A to B, B to C, C to D, and D back to A, it crosses itself. So because this one is crossing, this one is actually not considered a polygon. They tried to draw a quadrilateral, and this one crossed itself, so it's neither convex nor concave. It's not a polygon at all. Now let's go over a couple review topics here. If we have 2 different points, so one with an x and a y value and a second point with an x and a y value, the distance formula, the distance between these 2 points, is given by this formula here. D equals the square root of x2 minus x1, all of that squared, plus y2 minus y1, all of that squared. After you add these 2 up, you take the square root of the whole thing, and that would give you the distance between these 2 points. Okay? Again, if we had those same 2 points, we could find the exact middle of those 2 points, the midpoint. That would be found at the coordinate x2 plus x1, so the second x value plus the first x value divided by 2. So it's like finding the average of those 2 points. And then our y value of that would be y2 plus y1 over 2. It's like the average of our y values. Okay, so that would just be one single point then, xy, be the average of the x values, the average of the y values. That would be the midpoint, or the middle of those 2. Slope and the relationship of slope to parallel and perpendicular lines. Well, the slope between any 2 points is y2 minus y1 over x2 minus x1. It's the change in your y values over the change in your x values. How high did it go up, or how low did it go from those 2 points? And then how far over did we move? So the slopes of parallel lines are always equal. So if this slope came out to be 3 over 2, then a parallel line would also have 3 over 2. So m equals m. They're the exact same slopes. Slopes of perpendicular lines are opposite reciprocal. So I'm going to call it m over g. So let's say, again, we're using like 3 over 2. Then you would say negative. That's the opposite part. Opposite means negative. Instead of g on bottom, g is on top. Instead of m on top, m's on bottom. So m over g, the opposite reciprocal would be negative g over m. Okay? If these were the slopes of 2 lines, we would say that these 2 lines are perpendicular. And one last piece of review. Remember that regular polygons would be polygons that have all of their interior angles are equal to each other, or you can kind of think of it as all of their sides are equal to each other. Now these are biconditional. Remember, that means if we know that all of the sides are equal to each other, then all of the inside angles are equal to each other. If we know that all the inside angles are equal to each other, then we know for sure all of their sides are equal to each other. So these go hand in hand. Either way, that'll show that it's a regular polygon.